Just playing about with the stuff for a second. Okay, everybody, we are going to be doing some math integrals. Section 7.3 deals with a concept called rules for trig substitution, or trig substitution, essentially. And the substitutions are quite different from any other substitution you've done. The only other real kind of substitution are u-subs. But when you do u-subs, don't you do typically u as a function of x? So u equals x squared, u equals x squared plus 2, u equals sine x. That's not how these are going to work. You're going to be finding integrals of things that look like these three guys. And whenever you see these three guys, this is the trig substitution that you're going to get. I tend to call these x subs for short. So if you see an integral with the square root of a number, take away x squared, then the x sub will be a sine theta. If you see this, the x sub is going to be a tan theta. And this is the last permutation. If you see this, the substitution is going to be ax equals a secant theta. Now what's going to happen is that you're going to have an integral with some really ugly square root in it. You're going to use this, and we'll show you how to use it. And it's going to turn this horrible integral into an integral that has some combination of sines, cosines, secants, or tans. So it's going to turn it into questions that look like Friday stuff. And then you solve that question the way you did Friday's stuff, which probably means you're going to do some u-subs. And then you get the answer, but the answer is going to be in terms of theta. So what you're then going to have to do is to turn all those nice thetas into x's. And that entire process is pretty sneaky and kind of hard to get your head around until you've seen a few. So I'm just going to do some skill building exercise on how to pick an x sub. And that's it. We're not going to take it any further than how to do or how to choose the correct x sub for every situation. And once we've figured out how to do that well, then we'll start talking about solving a real integral. So suppose you had x cubed over the square root of 9 minus x squared. First thing you do is you focus on this ugly guy. Well, this ugly guy looks like that, right? Now, which one of these three, number 1, 2, or 3, looks like that guy?
1.
And so the x sub is 3 sine theta. You see where the 3 comes from? The sine theta is kind of guaranteed. Right, that's the first one done. Right, in this one, the guy you focus on is the x squared 25. Number 1, 2, or 3, which one looks like that guy?
3.
And which is the x sub that you will use then?
5 secant theta.
I'm not giving you any reason yet why you want to do that and why that's the x sub. You're just following instructions here, right? Here is an integral. This is the guy you look at. This tells you your x sub is. And that's pretty much going to be the first step in each of the integrals that are going to happen in 7.3. But we want to be good at this first step. So let me try another one. How about the integral of square root of Now, in this case, the guy inside the square root is this guy. Which one does that one work with? 1, 2, or 3?
2.
And what's the x sub you use in that situation?
A tan theta.
Right. In this case, 10, but in general, A. Are you beginning to see how you can look at an integral and decide what x sub needs to be used? And that x sub is not a choice. Yeah, I'll use the other one if I feel like it. No. That is the only x sub that will get you out of a hole. If you try and use a wrong x sub, right, one of these guys when it should have been that one, you'll pretty much know very quickly this is not the right rod, right? The thing will turn into some ugly monster that you'll never be able to integrate, and you kind of should know that. So hopefully, if you do occasionally screw up and pick that guy when it should have been this guy or whatever, you can tell when you start the process, probably about the 2 lines in, that that's not the one that you should have used. So far, so good. Right, so I'm going to zoom over to the homework. And don't worry about these weird triangles and things. We'll talk about them later. Right now, all I want to do is we're going to look at the integral and we're going to pick the right x sub. Now, I just thought of something. Some of you might not have written this down, so I'm going to give you a few seconds to do so. Unless you've got a really good memory, I guess you already have it in your head. These are the 3 guys, so I'll give you a few seconds to write them down on a bit of paper, because these 3 guys you're going to be using for the next 2 days, so you might as well get them written somewhere where you can find them. So if it's a squared minus x squared, use this one, an a squared plus x squared, use that one, and an x squared take away a squared, use that one.
I know you're gonna answer this question later, but are we really gonna take theta in terms of dx?
We are.
Okay.
Did you kind of see that coming, or you were wondering why it was written that way?
Yeah, I thought I kind of see that coming.
Yeah. Well, it's good to see things coming before they happen. That way it's not a surprise when I do it. Okay, I think I've given you enough time to have those guys written down. Probably should have, as I say, a card or a bit of paper somewhere where it's easy to find, because you're going to be using it a lot. I think, are we on the right screen? You can all see homework?
Yep.
Okay, now that one isn't a question because they tell you, right? But here's our first guy. Just tell me who the x sub is. In question 4, who is the x sub? We're going to go through all of them from start to finish in the homework. Who's the x sub?
9 sine theta.
Okay. We agree? Good. Who's the x sub going to be in question 5? Probably should make that a bit bigger. X sub in question 5. It's going to be x equals a something, right? That's kind of obvious.
A tan theta.
Okay, correct. Question 6, who's the x sub going to be?
3 tan theta.
Question 6, are we looking at my question 6? You might be looking at 7. Question 6.
Secant theta?
Yep. Right, now, the one underneath was 3 tan theta, so I'm assuming, well, actually, it's t equals 3 tan theta, so it is. Right, we're getting there. The one at the top here is question 8. What would you use as your x sub this time?
7 secant theta.
Okay. What about 9?
2 tan theta.
Right. What about 10?
9 tan theta.
Right. And the last one. So we've went through the entire homework. We just got one more to do. Oh, you darling. Not obvious. The last one's a bit sneaky, isn't it? Agreed?
Would it be 4/5 secant theta?
Very close. The 4/5 I like a lot.
Is it 4/5 sine theta?
Yeah. But you were 99% there. Okay, so right now, the only thing that we've really covered is that you're going to do a new kind of substitution called a trig substitution, or as I prefer, an X sub. And you've learned how to pick the right one. That's pretty much all we've done, right? How to choose the right one. So what we now need to do is show you the entire shopping list of what you need to do to solve one of these questions. Step 1, we've looked at. Choose the correct X sub. So choose that one, or that one. Step 2 is find dx. That's kind of cryptic, but you'll see what that looks like. 3, use substitution to change the integral into thetas. It's kind of cryptic, but when you see a question, you'll see what that one is. 4, find your integral in terms of theta. 5, construct a right-angled triangle using the X sub from step 1. 6, convert the answer back into x's using triangle in step 5. I did promise you at the start that this was going to be quite intricate, right? Quite messy, lots of things to do. But this is our shopping list. These are the things we need to do, and this is the order that we need to do them in. And quite a few of these are going to be, they are kind of short and cryptic, but when you see a few examples, you'll start to get a feeling for what do I mean when I say find dx, for instance. So, although some of you have kind of figured it out already. So here's my first example. Actually, I'll call it example 3 because it's question 3. And it looks like this fella. It looks like x cubed over the square root of x squared plus 81 dx. So I got my little shopping list. We're going to put this shopping list together and see what it comes up with. Okay, choose the correct X sub. We've already been through this, but maybe you've forgotten. Which one is this guy going to be?
9 secant theta.
Are you sure?
9 tangent. Yeah.
Okay, let's see what the choices are. X squared plus a number. That's basically this guy, which it makes it this guy. So that makes X equal 9 tan theta. Now, if you'd chosen either of the other two, in a couple of lines from now, you'd know that that wasn't going to work for you. And hopefully you would then go back and say, well, if it isn't that one, which one of the two that's left is it? Right. And hopefully that would come. Now, that's basically step one. Step two, so I'll put a little one beside it again. Step two is find dx. Now, what I'm going to do here is I'm going to differentiate x with respect to theta. Isn't that just like you do with your u sub? And what is the derivative? Derivative, mind you, of tan x or tan theta in this case.
9 secant of theta squared.
Great. Now, when we did u subs, isn't the next step the crossover? And that's step two finished. Now, why is that useful? See every x here and this dx, they're all going to get turned into something to do with theta, which is what step three says. Use your substitution to change the integral into theta. So let's see what that gets. X cubed becomes this guy cubed. The square root guy, x squared becomes 9 tan theta squared plus 81. And the dx becomes 9 secant squared theta. Oops, nobody noticed. D theta. Have you noticed that in this question, you don't have orphan x's? And you don't even hold on to some things so that they can get cancelled out later. Do you see, in a way, this just everything that's an x either becomes a 9 tan theta, right? Or if it's a dx, it becomes whatever this is. Although I don't have it in my shopping list directly. Oh, by the way, that would count as what, step three done now? Well, maybe not step three, but it's well on its way to being step three. Although I don't have it in my list, is there anything you think we should be doing here that would help us get the integral? I'm not going to leave it, right? Shouldn't we be tidying this up?
Convert everything under that square root to 1/2.
1/2?
The power of 1/2.
Oh, I gotcha. Maybe, but not yet. I'm going to do 9 cubed. Ugh. Just going to call it 9 cubed for the time being. That half power might well end up being true, but not yet. Now, all I'm doing here is just very slowly, I don't want to make my life too hard yet, pulling out all the bits and making them prettier. This guy and this guy, I'm just going to call it 9 to the power of 4. There's going to be a tan cubed theta. There's going to be a secant squared theta. Okay. There's always going to be a step like this. Do you see this ugly mess here? This ugly mess can become less of an ugly mess. What can 81 tan square theta plus 81 become?
$81 times in parentheses tan squared theta plus 1.
Okay, that's a good start. Yeah. It is not going to be that guy for long, because the way these things are designed, the guy inside the square root always becomes something nicer. Does anybody remember what tan squared theta plus 1 is? Trig identity. Tan squared theta plus 1 is somebody.
Secant squared.
So I'm now going to have the square root of 81 secant square theta. I have no idea what 9 to the 4 is, but can I just pull it out there and I'll worry about what it is later. So this thing here is going to be tan cubed theta, secant squared theta. And won't this guy be 9 secant thetas? Oh, okay, that works. Can I kill this 9 off with one of these and leave me with 9 cubed? Can I cancel this secant with one of them and leaves me with the secant? These questions are not short. But we have finally got to step 3. Well, actually, let's get my numbering system right. Step 4. Find the theta, find the integral in terms of theta. Would you agree this integral is now as nice as it can be, and it's got nothing but thetas in it? So I'm going to have to move this over. And let's find out what that is equal to. So this is just me repeating that last line. So it's 9 cubed. This fella. This fella. D theta. If you were wondering why there's only 2 sections this week, you probably aren't wondering anymore. Can you see how long this blinker thing's going to take us? Right. Forget where that question came from. Just treat it as a brand new question. Remember on Friday we did U subs? What U sub will solve this problem? And it's always one or the other, right? It's always secant or it's tan, right? One of those 2 U subs is going to solve this question. Any suggestions? Well, you know you have a 50-50 chance of guessing, right? It's either secant theta or it's tan theta. Which one is it?
Tangent.
Okay. Thank you for trying. Now, what would it be if I try tangent? Well, what do you get if you differentiate tangent? Let's talk it through. What's the derivative of tangent?
Secant square x or secant square theta.
Yeah. Is there any secant squares around here that might work with?
No.
Yeah, that's why I wouldn't choose it. But what's the derivative of secant theta?
Secant theta, tan theta.
Right. Have you noticed how much trig identities and trig derivatives and eventually trig integrals you need to be able to keep in your head here just to do this question? And if I do the crossover, get that. And if we do the isolate, get that. So this fella becomes whatever number 9 cubed is. That's a fella that looks like that. This fella I'm going to leave for a minute. And then I'm going to do a secant tan, do a d theta, and some cool stuff happens. One secant, it's a U. One secant cancels, one tan cancels. And, uh-oh. I have a tan squared, an orphan. Don't we have to figure out how to turn tan squared into U's? And the only way that's going to happen is if I can turn tan squared into something to do with secant squared. Yes? What's tan squared equal to in terms of secant squared? Yet another identity. There. What's tan squared equal to in terms of secant squared?
Secant take away 1.
Yeah. Which then becomes that guy. This fella here, especially the secant squared stuff and later on a different question, the sine squared stuff, is going to be part and parcel with what we're up to. Of course, knowing these integrals will help as well. This fella here, I guess I should bite the bullet. What in the heck is 9 cubed? I've been avoiding that for ages. 729, okay. 729. Power rule. Well, 729 divided by 3 gets me 243 U cubes minus 729 U plus C. What do I do with all these U's and U cubes now?
Turn them into secant theta.
And that guy has now got us to there. That's the real line D4. The other guy, I guess, was the star D4. Well, a long time ago, we started with this guy. This guy eventually became that guy. With this substitution, that guy eventually became this guy. Well, that's good, except we have one major problem. And normally it wouldn't be a big problem, but in these questions it is. Don't we need these answers to be turned into x's? Because that's the original question, was x's, not thetas, not u's. These guys need to be turned into x's. And that is not going to be a straightforward job either. Because we're now going to do step 5. We're going to construct a right angled triangle using this x sub from question 1. Using this x sub. So here it goes. The x sub that we had was 9 tan theta. And that's going to be used to create a right angled triangle. This right angled triangle's job is to find out what secant theta or tan theta or sine theta, whatever these are. and to convert them into x's. Now, right now, it's not actually the way I'm going to use it. If you divide both sides, isn't that equivalent to that? In other words, tan theta is x over 9, and I'm going to put theta here. Here's a piece of trig from 142. Remember SOHCAHTOA? What is a tangent equal to in terms of the right angle triangle sides? What's a tangent?
Opposite over adjacent.
So if you thought, yeah, forget about trig, here's a little piece of trig that you need to know, SOHCAHTOA. Now, according to SOHCAHTOA then, opposite over adjacent. Well, the opposite is x, and the adjacent is 9. And the third side, of course, is the hypotenuse. How am I going to find out what the hypotenuse is in this triangle?
Pythagorean theorem.
Which means square this, and stick it inside the square root. And if you do it correctly, you get that guy. Do you recognize that guy as this guy? That is a good sign that you're on the right tracks. Now, this particular integral has nothing but secants in it, but the next one is going to have maybe sine squared and a cos in it. And the next one's going to have a tan cubed and a sine in it, right? What you get is what you get. But whatever you get, this guy here is going to allow us to change that one. So let me figure out what secant theta is. Well, I could do secant theta if I had a good memory and just tell you what it is, but isn't a secant 1 over a cosine? So this is me doing a bit slow. Now, a cosine is what according to SOHCAHTOA?
Adjacent over hypotenuse.
So won't a secant be hypotenuse over adjacent? Agreed? And according to this, the hypotenuse is this guy. And the adjacent is this guy. Which means I can now get my answer. And I'll put the original question down so we can even figure out what that is the answer to. Well, it should be 243 secants cubed take away 729 secants plus a c. Do you think this is a good answer, or should we do some tidying up? Because we're pretty much finished. You think I should leave it like this, or should I try and make it a little prettier?
You get rid of the 9s.
Okay, then. Which is what I'm doing in my calculator right now. 243 divided by 9 is this guy, which actually is a third. And then you can have this guy cubed. And if you do the 729 guy, divide that by 9, you'll get 81 of this guy plus c. These are by far the longest integration questions you are ever going to encounter. Page 1, page 2, page 3. I guess if you write really small, you could probably squeeze it into a page or a page and a half. And if you write really big, or even bigger than I do, you'll probably take 4 pages. Let's look at the working then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 lines of working. 18 opportunities to do an oopsie. You're going to do these homework questions and they are going to make you old, because 18 lines, every single one of them, couldn't you drop a 9? Couldn't you make a plus, a minus? Couldn't you do a secant when you should have said sign, or whatever else it should be? And you have got to fight your way through, and eventually, hopefully, get the right answer.
Professor,
Yes.
I had a question about the right triangle. I
Uh-huh.
was confused. How did you get the lengths of the legs of the triangle?
Okay. From x equals 9 tan theta, I divided both sides by 9 to get this. And I know that the tangent is opposite over adjacent, so that makes the opposite an x, and that makes the adjacent a 9. So from this triangle, the opposite goes here, the adjacent goes here, and the hypotenuse goes here, right? From opposite, adjacent, hypotenuse side information. The opposite gets an x, the adjacent got a 9. And then Pythagoras says that the hypotenuse is this guy squared plus this guy squared, and then you take the square root of it, and that's how I got the third one.
Okay, that makes sense. Thanks.
Are we good?
I had a question about when you canceled the 9, you didn't have to cube it first, right?
I did. I went 243 divided by 9 cubed, and
Okay,
it came out
makes
as 0.333, which I know is a third. In this case, I just did 1 9 because that's all it was. Right. That question took us close to half an hour, and I think you've got 11. So you do the math. You're going to be spending a lot of time on these, aren't you? Now, that's probably the slowest one I'm going to do, right? Because we had to talk about step 1 and step 2. But I'm going to try and do one more. And at least I'll get as far as we can go. So this is question 4, or something similar. And it's going to be an x squared over the square root. I'm getting deja vu here. Oh, that's because we did them earlier on. Okay, it's okay. Anybody got a good memory? I've got the little guy beside him, whatever. What's the x sub that's going to work with this fella?
Nine sine of theta.
Check it out. Top one, right? So dx by d theta is going to be 9 cosine theta. Crossover is going to be 9 cosine theta d theta. Stop. These guys only do 3 lines instead of typical 4. X squared is going to become 9 sine theta squared. This fella is going to be the square root of 81, take away 9 sine theta squared, and the dx is going to turn into 9 cosine theta d theta. So far, so good? You happy with that became this? Okay. The next stage is just getting the thing tidy. So that guy gets you 81 sine squareds multiplied by 9 cosines. This guy in the square root becomes 81 take away 81 sine squared. You know, if you're going to do this question correctly, won't this ugly square root stop being a square root in a few lines? So let's see what we got. I'm going to have to do another multiplication here. 81 times 9. Okay, so that times that is 729. I have a sine squared theta. I have a cosine theta. That's good. Okay, 81, take away 81 sine squareds. 81, take away 81 sine squareds. What you going to get?
You factor out 81.
Okay, and that's going to get you 1 minus sine squared. And what's 1 minus sine squared going to be?
Cosine squared.
Right. So if you do both of them together, do you see you get 81 cosine squareds, and it saves me having to write 2 lines. Are you okay with those 2 lines becoming 1 line? Some of you get really brave. I'm not one of them. But you might even miss that line and go straight into this line. What does the square root of 81 cos squareds get you?
Nine cosine. Yeah.
Yes. You notice the square root goes away. Me personally, I wouldn't want to do it, but some people who are good can go from that line straight to this line and save themselves a little bit of work. And we all like that, right? Now, cancel. I'll do the number guy. 729 divided by 9, I think is 81, and it is. Good. Anything else I can cancel here?
Cosine?
And we are now left with that. So when you get to the stage where the integral is in terms of theta, which is here, you just have to remember last week's work. Because sometimes it's U subs, right? And sometimes it's other techniques. This one is deceptively simple because it is not a U sub. It's a trig identity situation. Does anybody know something that I can turn, here we go, sine squared theta into?
The half angle I did.
Okay, so it's 81, 1/2, 1 take away the cosine of 2 theta, d theta, which gets me 81 over 2, the integral of 1 take away the cosine of 2 theta. Now, isn't that going to be a lot easier to integrate than what might have happened, right? It's relatively straightforward. It's going to be a theta. A cosine, when you integrate it, gets you a positive sign. So a negative cosine gets you a negative sign. Because it's a 2 theta, you get a half. Are we all happy about that guy? And really, just to keep life relatively clean, let's just distribute the 81 halves and make it good. Right, we're here now. We go back to our original X sub. And we are going to create that right angle triangle. Now, X is 9 over sine theta, so that's X over 9 is sine theta. According to SOHCAHTOA, what is a sine? SOHCAHTOA, what is a sine?
Opposite over hypotenuse.
So the opposite is the top guy, so that's x. And the hypotenuse is the bottom guy, that goes there. And can't we use Pythagoras to get the third side? According to Pythagoras, won't it be this guy squared, take away that guy squared, which is 81, take away x squared. And why do I know that that is good news? I can look at that, this bit here, the square root of 81 minus x squared, and I know that I'm on the right track. You see this guy? Same guy. If this thing here had been the square root of 81 plus x squared, then I'd be really worried, because then I know I screwed up in one of the many lines that I could easily have screwed up in. So far, so good. Now, what do I need to know the answer to? I need to know what theta is, and I need to know what the sine of 2 theta is. So I'll put a little box around this guy. I need to know what theta is in terms of x, and I'm going to use this guy here. If the sine of theta is x over 9, then won't theta be the inverse sine of x over 9? And I also need to know what the sine of 2 theta is in terms of x. Which means I need to look over here. This triangle can only tell me what sines and cosines and tangents of thetas are. It doesn't tell me directly what the sine of 2 theta is, or the tan of 2 theta, or anything else 2 theta like. But isn't there a formula that we can use from over here that tells me a different version of this? And the one I'm going to use is this guy. Which tells me that the sine of 2 theta is 2 lots of the sine of theta, which is x over 9, times the cosine of theta, which is adjacent over hypotenuse. So that's ugly square root over 9.
Can you pull your sheet up, please? Thank you.
You're welcome. Which is that guy over 9, which means that the sine of 2 theta ends up being 2 over 81 and x over this ugly square root. Phew. So we are ready to rock and roll. This guy here, the answer is 81 over 2 theta, which is the inverse sine of x over 9. Take away 81 quarters, the sine of 2 theta, which is this guy, and now I'm just looking at that and I'm saying that's as good as that's going to go, but these 81s cancel, these 2s cancel, and so what I really end up with is the best version of the answer I can get is that guy. Cancel, cancel, cancel. That's a minus. 1/2 of that guy plus a c. Whew. A lot to take in, isn't there? I think you're probably, if you're wise at least, you're probably going to look at this video again and stop and think, how did you get from line 5 to line 6? And then kind of talk it through in your brain to it kind of has a direction to it, you know? It's like alphabet, A, B, C, D, E, F, right? You go through, one step follows another, follows another. And if you keep to the flow, you will eventually get the right answer. Cool stuff. Making your brain think.